Some experimental designs depend on accessing the eye data in real time in order to implement the design, and may do so in a way that the gaze trigger component may not be suited for. The latest sample and buffered data components provide mechanisms for accessing the eye data in real time for any experimental designs that may depend on that gaze data for controlling what happens next in the experiment. These two components are based on different mechanisms for accessing the data in real time, and each has its own relative strengths. We'll discuss how each works in the context of examples that illustrate appropriate uses of each. First, though, before getting into the details of how to access and use the eye data online, it's important to understand that the EyeLink host PC will also be recording this same eye data to the EyeLink data file, or EDF file, during the session. And this EDF file will be copied into the results folder of your PsychoPy experiment at the end of the session. This EDF file should provide you with all the eye data that you may need for analysis. So, in cases where the experimental procedure does not depend on the real-time gaze position, you don't need to worry about accessing the eye data online. In an experiment where you indeed need to access eye data online to do things beyond the capabilities of the gaze trigger component, which are discussed in another video, there are two main methods for doing so. First, you can access the latest eye sample data via the latest sample component. This is the simplest way to access basic position and pupil size data, in that whenever you check it, you can also be sure that you are checking the very newest eye data. And second, you can access any of the eye data that you may need by using the buffered data component. This second method is a little more complicated in that data are provided in a buffered manner, but this method allows you to access not just the sample level data, but all the EyeLink data, including data associated with eye events, like the start and end events of fixations, saccades, and blinks. Moreover, this second buffered data method can also provide access to every single sample that is being recorded, rather than just the very latest sample position. Let's talk about the latest sample component first. The latest sample component provides a mechanism for automatically accessing the current eye position and pupil size data that are being collected by the EyeLink host PC, and for making that data available to your script in real time. When placed in a routine, the EyeLink sample data will automatically be checked and retrieved continuously during the time window defined by the start and stop properties of the component. The current eye position and pupil data will then be available to your script by referring to the latest sample property of the component. For example, if the component is called latest sample, then the sample data will be stored and accessible via the latest sample.latestSample property. The EyeLink GC window plugin example provides an illustration of how to access and use the latest sample data. This example implements a gaze-contingent moving window by using a latest sample component to access the data, and then using just a few lines of code in a code component in the trial routine to use that data to update the position of a moving window that follows the eye. The each frame tab of that code component gets the eye data by referring to latestSample.latestSample. Once a sample has been retrieved, its contents can be accessed by calling methods from the PyLink module, which is EyeLink's Python module, and which provides the EyeLink plugin with the Python methods and functions that it needs to interact with the EyeLink system. Here, the example first checks a variable called EyeUsed that is automatically created by the plugin and that codes which eye is being tracked, 0 being left, 1 being right, and 2 being both. Then it grabs the appropriate eye's sample data and finally accesses the gaze position via the getGaze function. The PyLink user manual that is included with the EyeLink Developers Kit that you installed during the installation process provides documentation for these functions. For simple cases where your script just needs to continuously access the ongoing position or pupil size of the eye, the latest sample component is often the best bet. If your script needs to access eye event data, which include fixation, saccade, and blink start and end data, or needs to build a list for your PsychoPy experiment containing the data of every single sample being recorded by the EyeLink host PC, then the buffered data component is a better option to use. In an EyeLink experiment, the host PC can provide any of the data that it is recording to the display PC by also logging that data to a buffer, which an application such as PsychoPy can then read from in order to access that data. The buffer data component essentially will read from that buffer for you and create simple lists of that data that can then be accessed by your PsychoPy script. The EyeLink Saccade plugin example shows how to use the buffered data component to check for the end of the first saccade in a trial where that saccade has an amplitude greater than 1.5 degrees of visual angle, and then in the trial when such a saccade is detected. When adding the buffered data component, you specify which aspects of the EyeLink data you will need access to by listing all the event types you will need in the event data types to include property separated by commas. Here there is only one type of data that we need, the end of saccades. But if you need any other events, you can hover your mouse over the property value to see what types are available. Each event type will be logged into a separate list, and the name of that list will be based on the component name you use and the event type of the list. For this example, because the component is called buffered data and the event type we need is all end of saccade events, the data that we will need to access and check will be stored in a list called bufferdata.endSaccList. You can additionally specify the maximum length of the list. Once the maximum length is reached, each new event that is added to the list will also result in the oldest event in the list being removed. The oldest event in the list will always be the first item in the list, or the one with an index of 0, and the latest event in the list will always be the last item in the list. In Python, you can access the last item in a list by using an index of -1. You can also choose to include spanned end events, which include events that started before the start time of the component and ended within the start and stop times of the component, and events that started within the start and stop times of the component but ended after the stop time of the component. Finally, if you need to access every single eye sample that is being recorded, then you can check Include Sample Data. This will result in a list being built for the sample data as well. The code component in this EyeLink Saccade plugin example shows how to actually access and use the end saccade event data that the buffered data component provides. Here, it first checks to see if the length of the list is greater than 0, meaning it has detected and logged at least one saccade event. If so, it accesses and checks the very latest end saccade events data to see if the amplitude is greater than 1.5 degrees. If that criterion is met, then it ends the trial. The latest sample and buffered data components should be placed below any stimulus and response components in the routine, but it should be placed above any mark events components and code components that are also used in the routine.